Hello everyone, so in this video what I want to discuss is a subject of mathematics and essentially applied mathematics, and this is related to the volume of a k-dimensional ball. So here k would be an integer, that would be 1, 2, 3, 4 or 1000, okay, and where this ball has a radius r. Now this volume usually is called a hypervolume. And one of the things that happens is that for some reason this pops up in basically many different areas of applied mathematics. So that can go from probability theory, that can be in quantum mechanics, that can also come in statistical mechanics. So it does come in various areas of usually analysis and geometry, and that's the reason why basically it's important to look at it. It does also come up as well in resolutions of integrals, in analysis. Okay, so the strategy I want to use in this video is twofold. So first, in the first video, I would present what I would call the pedestrian approach, which is essentially using Cartesian coordinates and try to find out what would be not the expression, but why such a strategy is bound to be difficult. Okay, and we are not going to derive the result that way. I'm going to illustrate it with the 3D case, but that's about it. So once we have agreed that this is relatively difficult and tedious to do it this way, then in a second video I will actually show a trick which enables you to do it in a couple of lines. Okay, so that being said, let's move on to the description of the problem. Okay, so description of the problem. So the description of the problem is as follows. You've got basically a domain omega, okay, which has to do with the set of all points such that x1 squared plus x2 squared plus blah 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 xk squared is less than or equal to r squared. Okay, so here of course I need to say that x1, x2, etc. in principle belong to the reals and etc. But that's kind of it. Okay, so this is, by the way, a ball that is centered at 0. So domain omega, which is of that form, and I want to know what is the volume of omega. What is the volume of omega? So again, so that's kind of a basic question, and the way we would do it, the pedestrian way in Cartesian coordinate would be as follows. We'll say, well, I've got this particular equation, so what I can do is first start by saying, well, this volume, let's denote first, denoted, I will call that Vk of r, and what I can see is that Vk of r, I can start writing it down, right? So first that would be the integral, and then I will go from, so what I will do here is keep basically all the positive values of the real coordinates. So obviously all these real coordinates can be positive and negative, and what I will do is focus on the positive part, because of course the negative part of each of them will contribute to the same in the same manner to the volume. So here I go from 0 to r dx1. Now because I actually go from 0 to r and not minus r to r, then I need to add a factor 2. Okay, now so that's for dx1. So x1 is a variable which I've decided will go from 0 to r. Okay, now the issue that I have is that since x1 now, so x1 is fixed, okay, therefore x2, for example, cannot go up to r, because if x1 is equal to r, then x2, if x2 is equal to r, then obviously you will violate this inequality here. So the maximum value of x2 in this particular strategy has to be basically accounting for the possible values that x1 is taking. Okay, so in that particular sense, therefore, essentially if I want to write it down here, x2, so I will write it in this laser stuff, so x2 squared has to be less than equal to r squared minus x1 squared, okay, because once x1 squared is given, then x2 squared of course cannot take all possible values from 0 to r. So at the end of the day you would have from 0 and then square root of r squared minus x1 squared. Now of course notice that because this is an equation for x2 squared, you've got a possibility for plus or minus here. But as I said, we focus on the positive one. But because we focus on the positive, then it means we need to multiply by 2 again. Okay, now essentially this strategy can be applied. If x1 and x2 are kind of given, then I can't give all possible values from 0 to r to arc3, to x3. Therefore, I need to basically put the limits of integration for x3 accordingly to account for the values already taken by x1 and x2. So what I will get is dx3 and then 0 and then r squared minus x1 squared minus x3 squared, minus x2 squared, sorry. Okay, and here again I want to highlight that you would have plus and minus. However, because I focus on the pluses, then I get this factor 2 here. And what I get here is that you probably see where this is going. At the end of the day, I will get dxk, okay, and then from 0 to a quantity which would be r squared minus x1, and then minus xk minus 1 squared. Okay, so that would be the way to write it down. Of course, because you would have here again plus and minus, you would have to have accordingly factor 2's. So here you would have 2, then you've got a bunch of 2's as well in between, and overall you've got k factor 2. Okay, so basically it's 2 to the power k that you get. Alright, so that's the expression for it, and what we can do is, in case you don't believe me that this is how it should look like, then we can try to look at the k's for 3 dimension. Depending on your education, this could be something you've seen already, or sometimes you simply have been given the expression for it, or a shorthand strategy to derive it, and it's quite rare that people have done it in full Cartesian coordinate system. So let's have a look. Let's have a look at k is equal to 3, just to see, you know, how difficult is this particular task if I follow this very general strategy. Well, v3 of r would be then 2 to the power 3, and then I simply have 0 from 0 to r dx1, then from 0 to r squared minus x1 squared dx2, and then I would have from 0 to r squared minus x1 squared minus x2 squared dx3. Okay, now this first integral with respect to x3 is trivial, right? Because I've got to integrate 1. An integral of 1 is simply x3, so that's fine. So what I get is 2 to the power 3, then dx1 from 0 to r. Then I get 0. What I will do here is basically I will call this square root of r squared minus x1 squared. I will call it r1 for simplicity of notation. And then, and then what I get here is r1 squared minus x2 squared. Okay, so and here I need to specify with r1 equals r squared minus x1 squared. Okay, now what we need to do is basically calculate this particular integral. Now of course nowadays you can put an integral like this into Wolfram alpha or whatnot. You can probably find the thing, but what I want to do is try not to kind of cheat and find out what would be the outcome, just in case you don't remember and so on. So I here is the integral from 0 to r1 dx2, and what I want to do is take r1 squared outside of the square root. So then I've got 1 minus x2 squared over r1 squared, and that's what I've got here. And the way this particular integral is solved in general is by substitution. Okay, so the trick is to say, well, let's call sine of u is equal to x2 over r1. So because it's substitution, I need to also work out the integration measure. So I get that d sine u, okay, would be cos u du. And because sine u is equal to x2 over r1, I will have this is equal to dx2 over r1. Likewise, I need to work out the interval for the limits of integration. So if x2 belongs to the interval 0 r, so I would say that differently. If x2 over r1 belongs to the interval 0, 1, then u, in this particular case, will belong to the interval 0, pi over 2. Okay? So then, what, this being written, then what I can do is say, well, then I is equal to the integral from 0 to pi over 2. Then I need to not miss out things. So dx2 will give me r1 cos u. Okay, so I've got du first, then I've got r1 cos u, and times r1, and then 1 minus sine squared of u. Now, because I'm in the interval of angles 0, pi over 2, then basically this can be substituted by cosine of u. Okay, because 1 minus sine squared of u will be cosine squared. And what I get in the end is basically the following. So 0 pi over 2, then du r1 squared cos squared u. Okay, now what I can do is use the double angle formula, and I will get something like this. So r1 squared, then 0 pi over 2 du, and then I get that this is 1 plus cosine 2u over 2. Okay, so that's a typical formula from trigonometry. This is something you can see in high school or sometimes in year 1 of university, and what you end up with in the end is you will get r1 squared integral 0 pi over 2 du over 2. Okay, and you will get plus, so r1 squared over 2, and then 0 pi over 2 du of cosine 2u. Okay, now this first integral will give rise to r1 squared, and then pi divided by 4, and the second integral will actually give rise to 0. Okay, so this one here would be equal to 0, and you can see that because if you take the primitive of cosine 2u, you will get sine 2u, and sine 2u when u is pi over 2 will give pi, so that you will have 0 on both ends, if you will. So at the end of the day, you get that v3 of r would be 2 cubed, and then integral from 0 to r of dx1, and then here I would put pi over 4, and then you get r1 squared, which is r squared minus x1 squared. Okay, so at the end of the day, you get 2 pi, okay, and then 0 r dx1 r squared plus 2 pi 0 r, and then well, minus actually, and then dx1 x1 squared. So this will give rise to 2 pi r cubed, okay, minus 2 pi, and then r cubed over 3. Okay, so it's 2 pi factorize r cubed minus r cubed over 3, and that will give you 4 thirds of pi r cubed, okay, which is the result that you know. Okay, so just to show you how that works, so in some sense you could say QED because most of us have seen before this type of expression, but the point here is to show you that it works. But what it shows you as well is that it's not easy to necessarily work it out. It can be tedious, and if you've got to do it for the general case, then that becomes complicated. So if you know the number, you can calculate it. It's tedious, but you can do it. But if you are given simply the number, you're simply given k and you need to find the general expression, then this is probably not the best way of dealing with it. Okay, so in the next video what I'm going to do is precisely discuss well, 2 strategies, but one I'm not going to really delve into it, and show a quick trick to find out this particular value.